Hello there, this is Eustaquio of MEE21, and this is Basic Electronics Engineering Experiment Vlogs. And let's get straight to the video.
And his name is John C.
So, in this video, I'm going to talk about the experiment 4, which is this. Experiment number 4, diode application, clippers and signal generator familiarization. And here are the objectives. First is to become familiar with the functions and uses of a signal generator. Second is to become familiar with the different types of AC signal. Third is to distinguish the difference between a series clipper and a parallel clipper. Fourth is to distinguish the difference between a positive and negative clipper. And last is to determine the effect of an additional DC source to a clipper circuit. And here are the equipments and components used. And since it's online, we're gonna use the equipment from the Multisim virtually. So first is one voltometer, and the next is one oscilloscope, and two 1N4001 rectifier diodes, one multi-tap transformer, one kilo ohm resistor, and one 3.3 kilo ohm resistor, one breadboard, one signal generator, and one DC power supply alligator clips and connecting wires. And here are the schematic diagrams. We are given 4 figures. Figures 1, 2, 3, and 4. So here are the procedures. Here's the procedure for signal generator familiarization. First is to connect channel 1 of the oscilloscope to the output terminal of the signal generator. Second is to press the button with the sine wave figure. Third is to press the 100 Hz button, turn the frequency adjust knob until you can see 60 Hz waveform on the display of the oscilloscope. Fourth is to adjust the amplitude knob until you can see a sine wave with a peak-to-peak value of 100 volts. 5 is to draw the waveform appearing on the display on your data as output number 1. Repeat the steps 2 to 5, this time with a 50 volt peak to peak and 500 Hz square wave, that is for output 2. 7 is to repeat steps 2 to 5, this time with a 10 voltage peak to peak with 2 kHz triangular wave, this is for output number 3. And answer the question in part 5. So here is part 5. And this is the multisim that I used. Channels A, negative to the ground. Channels B, negative to the ground. One resistor with 1 kilo ohm. One virtual diode with 1N4001. One function generator. And one multimeter, voltmeter. Here is the oscilloscope. And from this multisim, I've gathered this data. Output 1, output 2, output 3. For signal generator familiarization. First, it has the sine wave. The output number 2 has the square waves. The output number 3 has triangular waves. And to answer the questions. First question for the activity signal generator familiarization. So, first question. What are the significant parts of the function generator that was used in this experiment? And what are their functions? The function signal generator can give off three varying waveforms. These waveforms are sine, triangular, and square waveforms. The device can adjust the peak-to-peak voltages and their frequency to adjust the time cycle and the output of the wave. For the second question, how do you consider a signal generator? An input or an output device? Explain your answer. For me, I consider the function signal generator as an input device because it simply supplies its own voltage and the output changes, not only from the function generator, but it also changes the output from the component itself, as shown in the diagram. So let's move to the second procedure: unbiased series and parallel clippers. And the procedure first is connect the circuit in figure 1. Second is to set the signal generator to sine wave, 100 voltage peak to peak and 60 Hz input signal. 3 is to draw the output waveform as output number 4. 4 is to try reversing the diode, observe what happens and draw the output waveform as output number 5. And 5th, try changing the input signal to a square wave, observe what happens. 6 is to connect the circuit in figure 2. 7 is to repeat steps 2 to 5, 6 and 7. And here are the data that I have gathered from this Multisim. But let's check it square. So for outputs 4, this is what I have gathered. A voltage peak to peak of 100 from output 4 and a voltage output of 15.583 volts. And for output number 5, have the same voltage peak to peak 100, and because from the procedure it is said that we should reverse the diode, and this what happened. The voltage output become negatively charged, which is negative 15.583 volts. So answering the questions, referring to output 4, what type of clipper circuit is this? Based on my observations, the output 4 is a series negative clipper, and the output 5 is a series positive clipper. So what are the effects of changing the polarities of the diode? The diode acted as a switch for each other half cycles. And for output 4, it is output biased, so it is a closed switch. And for output 5, it is reversed biased, so it is an open switch. So what happens to the output when the input signal was changed to a square wave signal, and why? The output voltage become 24.61 volts, and the peak-to-peak voltage become 100 volts exact. Because having a square wave with only the negative showing, because it is a series positive clipper circuit. So on to the last last procedure is the bias series and parallel clippers. My bad. So the first step is to connect the circuit in figure 3. Set the signal generator to sine wave 100 voltage peak to peak 60 Hz input signal. Draw the output waveform as output number 8. Try to reverse the polarity of the DC source. Observe what happens and draw the output waveform as output number 9. Try changing the input signal to a triangular wave. Observe what happens. 6 is connect the circuit in figure 4, which is gonna be output 10 and output 11, and repeat steps 2 to 5. So here are the data that I have gathered for that. 8 and 9. Here is where I gathered that data from this Multisim. You can see here's a resistor, a DC power source, the oscilloscope, the ground, one diode, 1 voltmeter. Same here, but the DC source is here with the diode connected in parallel. So here are the data that I've gathered. It had the a voltage output of 17.10 volts, and for output number 9 it had the voltage output of negative 17.10 volts. So output 8 is a bias series positive clipper, and output 9 is a bias series negative clipper based upon my observation. What are the effects of changing the polarities of the DC power supply? It does not affect the waveform, but only when the diode is also reverse polarity. That is when it has an effect. So what happened when the input was changed to a triangular wave? In output number 8, the voltage peak to peak changed to 90.355 volts, and the output voltage changed to 4.992 volts, differentiating the output from sine waveform. So this is output 10 and output 11. For output 10, it has the voltage output of negative 17.10 volts, and for output 11, it has a voltage output of negative 14.11. Referring to output number 10, the clipper circuit is a biased parallel positive clipper, and output 11 is a biased parallel negative clipper. So what are the effects of changing the polarities of the DC power supply? The DC only changes the output voltage of the circuit, not what is stated in the previous outputs. So, and last question is, what is the difference between an unbiased and biased clipper? How does it affect the output waveform? Biased clippers limits the output waves and show where the wave is only formed. It is because of the reverse bias of the diode at the F cycle, and the unbiased, on the other hand, is not limited and shows the full waveform. And for the conclusion, the student engineers learned that the function generator is an input device which has 3 types of specific waveforms. It has function that gives a set of parameters of frequency and voltage peak to peak values to manipulate the waveform and its values. In this experiment, the student engineers used 1 volt ohmmeter, 1 oscilloscope, 2 1N4001 rectifier diodes, 1 kilo ohm resistor, 1 signal generator, 1 DC power supply, alligator clips, and connecting wires. They become familiar with the functions and uses of a signal generator, the different types of AC signal, and they were able to distinguish the difference between series clipper and a parallel clipper, and distinguish the difference between a positive and negative clipper, and determine the effect of an additional DC source to a clipper circuit. And that's it for this video. Thanks for watching, and stay safe always.